Hey guys, it's Christian, and today we're taking a look at how to block stupid ads and manage DNS in your home network with Pi-hole. I just recently deployed this in my home network, and guys, I can just tell you Pi-hole is absolutely incredible. It's an easy-to-use network-wide ad and internet tracker blocker that protects all of your devices in the network from unwanted content without having to install anything on the client devices itself. So that means it works on all of your computers, all of your laptops, your phones, and even smart TVs. And it is super small and efficient. This thing runs on any device, just like a small Raspberry Pi, but of course also on all of your Linux-based home lab servers. And it provides you an easy-to-use web interface with statistics about all of the DNS queries, with DNS configuration options, and even DHCP functionality. And the best, it is free and open source. So in this video, I'm going to show you how to easily deploy Pi-hole to your Docker host or Swarm cluster with optional Traefik reverse proxy integration, so you can get rid of any ads and trackers for all of the devices in your entire network. I think that sounds pretty interesting, right? So let's take a look together. Before we do that though, I quickly like to show you how you can easily manage all of your tech and home lab projects, because if you're juggling around with different tasks and projects like me at the same time, you can lose track pretty fast. So that's why you should definitely use Monday.com, the intuitive all-in-one work platform where you can collaborate efficiently with a team, manage complex projects, and even automate repetitive tasks. You can easily create to-do lists with next actions that you're planning, or create custom fields with additional nodes, manage priorities, or plan timelines. If you know me guys, I absolutely love the Kanban board style, so that gives you a perfect overview of all of this stuff that's going on. But of course you can also do some pretty advanced stuff like connecting different boards and adding dependencies between the tasks. It is really super cool. And of course it doesn't only work for your personal projects. Actually, it gets more interesting to use such a platform when you're managing projects in a team. You can start with a free plan that gets you up to 2 seats with free boards, unlimited docs, and 8 column types, which is great for smaller projects, but you can also upgrade to other plans to increase the features and capabilities of Monday.com to automate coordinating emails, sending out files and Slack messages, and organize your team's projects and collaborate effectively. To easily get started, check out Monday.com. Of course, I've put your link to this in the description box down below. Alright, so now let's get started with Pi-hole. First of all, it might be interesting for some of you to know how it actually works. And to understand this, we need to talk a little about DNS and DNS black holes. If you're already familiar with how DNS works, then bear with me for a moment here, because I just need to make sure that everybody is on the same page. But I'll make it quick, yeah? So DNS, the domain name system, is essentially the phone book of the internet. So when you type in a website's address in your browser, like christianlepper.de, your device doesn't actually know where this website lives and which server to connect to, so it needs to convert that human readable name into an IP address to establish a connection. And here's how that normally works. Your device just sends out a DNS request, a DNS query on port 53 to your DNS server. That is usually the DNS server that gets configured by your DHCP server on the network, which might either be provided by your ISP or by a public DNS service like Cloudflare or Google, depending on what you have configured. Then that server responds with the IP address of that website, and the device connects to that address to load it. And this happens constantly in the background, yeah, for every website that you visit, and every website itself might contain additional elements from other sources as well that need to be resolved, including legitimate ones like images or scripts that are loaded from other locations. But also every tracker, every advertisement block usually has its own DNS name, because it's coming from a different server than the original website. And your devices are making hundreds or thousands of DNS queries every single day to load every part of the website that is included. And now here comes the interesting point where Pi-hole jumps in. Because when you configure Pi-hole as your primary DNS server, it starts intercepting all these DNS queries. Pi-hole checks the requested domain against its blacklist, so which is basically just a massive database of known advertising and tracking domains. And if the domain is on such a block list, then Pi-hole doesn't forward that query to an upstream DNS server. Instead, it responds immediately with a null address, typically 0.0.0.0, which is also called a black hole, where the original DNS query from your device disappears into a black hole. So basically telling your device, hey, this domain doesn't exist, or it points to nowhere. Now, this sounds really great, as it would be the best option to block any ads and trackers, and yeah, it is a great technology. However, the crucial thing to understand here is that this happens at the very beginning of the network processing, so even before any HTTPS or HTTP connection from your device is established. So Pi-hole is making the blocking decisions based purely on the domain names, not on the actual content that's being served. And this actually comes with a few advantages, yeah, such as speed improvements, because your device is making less requests and less connections to load a website. You will, by the way, notice that some websites even load faster than before. However, it also has a few downsides because, first of all, these lists need to be highly accurate and, of course, up to date. Otherwise, you will run into false positives or false negatives where some elements of the website don't actually load or some advertisements aren't blocked because that domain isn't updated on these public lists. But it also is not able to block everything because bigger services like YouTube, a very prominent example, will load trackers and advertisements from the exact same domain as the rest of the content, which is the main reason why Pi-hole isn't able to block advertisements in YouTube videos. So it isn't a silver bullet for everything, but I think it's blocking like 95% of all the ads of any websites that I've at least seen. So it is better than nothing to have Pi-hole in place. Now, excuse me for the long introduction, but I thought it might be interesting to know how the technology works to get a better understanding of the capabilities and also the limitations of this program, and then you can make a better decision if you want to use it or not. But just like I said in the beginning, I recently deployed this in my home lab network because I thought it might be good to have some better statistics and some better insights into the DNS queries and literally just have more control about what's going on. And of course, it's also blocking 95% of the stupid ads and trackers without having to install anything on all of my devices. So you actually don't need any browser extension like AdBlock or something like that. And you can just install this thing on nearly every device that's running in your home lab. I think if you're watching or following this channel, you're pretty familiar with how that actually works. You might have a home lab server in place. Maybe you're just starting out and you want to run this thing on a small Raspberry Pi that's just running 24/7. But yeah, you mainly have all the options to deploy this anywhere you want. Yeah, on the official website, piehole.net, I'll put you that in the description as well. Here it is explained how to install this thing on any supported operating system. There's even a Docker Compose template that you can start with, but of course, you can customize several things here and there. If you want to deploy this to Docker Swarm, or if you want to integrate this with your Traefik reverse proxy, it's getting more and more complicated to create these templates here. But I've got a super simple solution that I just want to show you. Of course, we're using my newly created boilerplate CLI tool that you can easily just download from my Git repository with this one simple command script. So just run this on your Linux or Mac device. You can also use this on WSL2, for example. And then you can use the boilerplates command to start creating a Docker Compose template that is really tailored to your specific environment, where it's automatically adding all the labels and the configuration settings. I'm just going to show this to you. So let's open a new terminal. I'm going to create this in a new project directory. By the way, if you were using the boilerplates before, you need to upgrade to the latest version 0.07 that I just released. This will add functionality that the new Pi-hole variables and Pi-hole templates is needing. So with the boilerplates compose show Pi-hole command, you can get a deeper look at the template and what files are being created by it. So here you have several configuration options. I just want to go through this with you by just creating a super simple boilerplate with just the default configuration. So let's just execute generate Pi-hole. This will again print out all of the enabled variables and the default settings that I have configured for you, and then we can start customizing them as well. So first of all, you can configure the service name from Pi-hole to Pi-hole test1, for example, or something else. You can set the container name that is only relevant if you're not using Docker Swarm, by the way. Set your time zone. This is also pretty important for any DNS or NTP functionality. Then you can customize the user and group ID. By default, it is set to 1000 if you have multiple users on your server. And of course, you can customize the container restart policy. Unless stopped is, I think, the best default setting. And here I've added a variable for the web interface admin password. When you don't enter a password, it will auto-generate a secure random password from the templates and put this password into the .env Pi-hole and env.secret files in here. So make sure to exclude these two files from your repositories. I'm just gonna hit enter to auto-generate a new password, and then we can decide the Docker network mode. In the newer versions of the boilerplates CLI tool, I make this mandatory because now the Docker network mode can be changed to different values. If you're not familiar with the network modes, how they work in Docker, and if you don't need DHCP functionality, you can completely ignore this. So I just created this template this way to make it expandable or customizable, so to speak. But I don't want to enable DHCP functionality on my Pi-hole instance because I just want this for DNS. I just want this for ad and tracking blocking. But just know that in this mode, DHCP will not work. Now, it still creates a new Docker network called Pi-hole network. If you want to customize the name, feel free to enter something else. And if you want that to be connected to an external network, so a Docker network that is managed somewhere else, you can enable the external flag for Docker network to connect this to an existing one. All right, so now we come to the port part, and that's kind of interesting because you need 4 ports for Pi-hole. So if you're using bridge mode, then you can expose the HTTP port on a separate port than the default port 80 and the HTTPS port on something else like the default port 443. And then it's also exposing the default DNS port 53 on both TCP and UDP, and also the NTP port, so for the time service, on the port 123. So you can customize these values, but I would definitely not recommend you to change the default DNS port, because on your devices, you usually cannot configure this DNS port. Now, you can also enable Traefik if you want. Again, this will allow you to protect the internal HTTP servers with trusted TLS certificates. I suppose you've watched some of my Traefik videos. If you haven't, you can check them out. I'll put your link in the description. But in this example, I don't want to enable it. And I also don't want to enable Docker Swarm. I've deployed this in my home lab using Docker Swarm. I will go through this in a minute here, but if you just want to have the super simple version of the template, you can just go with the default values. And now we can say generate these files. Yes. All right. So now it will also present you some next steps here deployed to Docker. So you have to go to this directory, upload this to your server, and then just hit docker compose up-d. So why not just do this right now? So let's go into this directory and let's just copy this command here, docker compose up-d, and let's run this. This will pull down the latest version of the Pi-hole image and start up the Docker Compose project with all of the configured variables above. And then we can check if the Docker stack is ready. So yeah, it's currently created. And of course, we need to access the web interface using HTTPS. That is always the best because then the connection is encrypted. Of course, you need to replace this here with your Docker host IP, so where you have deployed this. Currently, I'm just starting this on my local device, so I can just use the local host address. You get a certificate warning if you're not using Traefik, yeah. And then this is the web interface of Pi-hole. We still need to grab the password here, so if we take a look at the directory, I've also created a .env Pi-hole. That's this file here, so where the password is stored securely. So we can just copy this here and log in. And that is the web interface of Pi-hole. All right, so it's as easy as that to deploy this. By the way, before we go through some of the functionalities and features, I still want to show you some other deployment methods that the boilerplates script is capable of. So for example, if we want to change something, I've just set this to dry run. No interactive, so to just generate a new template without having to customize anything in here. And I want to enable Traefik, for example. So if we just set Traefik enabled to true, so this will generate a new template. You can see that these two ports here, HTTP and HTTPS, are disabled now because they are not relevant anymore when you're using Traefik. You can see in the port section, I've removed this, but added the labels for Traefik. Now, if you want to customize the host rule, you can also change these variables in here. So Traefik host, either go through this interactively or just set Traefik host equal and then Pi-hole server test1.home.crave.de. Can of course also customize the Traefik network name if you need to set this to something else, or customize the certificate resolver and the entry point and stuff like that. So then you can easily implement this with Traefik labels that are pre-configured. Of course, you can, after generating the templates, always make adjustments to the actual files, so make changes if needed. I'm also going to show you something else here. If you want to set the network mode, for example, let's set this to host, so then you can see what's happening here. This file gets dramatically smaller because we don't need to expose any ports automatically, so the network mode host will make sure that the Pi-hole service will be deployed just as it would not be in Docker, so it won't create this isolation layer. And the other network mode is MacVLAN. So this will enable these variables here, where you need to set the IPv4 address of your Pi-hole service. So which IP address you want the Pi-hole container to have, what is the parent network interface it should be connected to, and you also need to specify the subnet. So with a /24 or /16, depending on how large your network is, and also set the default gateway, so the IP address of your router in the network, and then Pi-hole will be deployed just like as it would be a separate physical device that you connect to your network switch. Now, again, I personally don't like to deploy Pi-hole with MacVLAN or network mode host, because that automatically disables Traefik and the container will be accessible without any reverse proxy. So you can directly access the HTTP port on port 80 and 443 for the HTTPS part. So that's why I personally don't like these two modes. But for some people, it might be easier or simpler to deploy this way. I also want to show you one more thing, and that is the new swarm configuration that I added to the latest version of the boilerplates. This will allow you to configure Pi-hole in Docker Swarm. However, here we get an error saying that the variable validation failed, swarm placement host is required but not provided. So I've made it required to set a specific constraint for the target hostname placement. So in my example, if I want to deploy this, I need to set this to server prot 1, for example, or server prot 2, to make sure that Pi-hole will always be started on that server, which, by the way, makes also the persistent volume stuff easier, because then you don't need a shared volume or an NFS volume. So again, Docker Swarm comes with its own challenges. I've explained most of this in my Docker Swarm tutorial. I will also link you this in the description. But just know that this will generate a template. By the way, let's, for example, do this maybe with Traefik enabled, that exposes the DNS port on the specific Docker Swarm host only, which means you can run different DNS servers on the other Swarm nodes if you want. And it will also create this with persistent volumes and with a secret for the password. So here, this will be stored in the .env secret file and will automatically be loaded into the Docker Swarm service. All right, so again, I don't want to confuse you with too much options, but I think it is necessary to provide these templates with a lot of customization options so you can really use them to deploy Pi-hole to any kind of environment that you need. Again, if you want this to be super simple, you can just deploy the default template and just run this on a Docker server with a bridge mode and make this IP address where you deployed this on your primary DNS server. This is the next step that I want to show you, because only when you're using Pi-hole as your primary DNS server, it enables the blocking functionality. Until you do this, Pi-hole is just sitting there waiting for DNS queries to arrive, but it doesn't actually get any. So you can now just go to every device and configure this in the settings. Like on macOS, for example, you just need to go to Network, go to Ethernet, and then go to Details. There you can configure the DNS server and switch this from the primary gateway address to your Pi-hole instance. However, if you need to do this on every computer, every device, every phone, every laptop, every smart TV, that gets tremendously complicated and annoying. So I would recommend you to do this a much smarter way. And that is by modifying the DNS server that your DHCP server on the network provides to your devices. And then when they receive a new IP address from the DHCP server, they also get the new IP address of your Pi-hole instance as the primary DNS server. Now, how to do this, of course, depends on what type of home router or network firewall you're running in your home lab. I just want to show you an example on my OpenSense firewall. I've recently deployed this as my primary firewall. By the way, video tutorial is also in the description for this one. And here you can very easily do this when you go to services and then go to your DHCP server. I think I got the ISC DHCP server 4. Here, for example, you can see the configuration for the LAN interface. Here's the DHCP range, and by default, this field here, DNS servers, is empty because it will use the system default DNS server, which is basically the IP address of the network interface of the firewall where the devices are connected to. But here you can type in the IP address. So for example, if I deployed this on my server Pro 2, I just need to get the IP address here. It is the 10.20.0.3 and set this on my DHCP server as the new DNS server. So in the future, I will automatically enable this. I haven't done it right now because I'm still in testing phase, but I can demonstrate this to you, how that would work on my Mac. So for example, if I go to something like Tech Radar and I want to read some articles here, you can see we got a lot of advertisement blocks here and there. So it's just horrible. You have more ads on this website than actual content. It is, yeah. And if I change my DNS configuration to, let's grab the IP address of that Pi-hole instance. I will show you this on my production instance, by the way. So then my DNS requests are not going to be sent to my firewall, they're going to be sent to Pi-hole. You can see that the advertisement blocks are still there, but there's no element loaded. And if we return back to Pi-hole, you can see that 77 queries have been blocked just by opening this one website. Yeah, just imagine you're browsing through the web. So let's take a closer look at the Pi-hole's interface. It's actually kind of interesting. What happens here, you can see the total queries, the queries blocked, the percentage blocked, and the domains on the list. So there are over 100,000 domains on the block list. You could also manage them here in the lists menu, by the way. So currently there's only one list. It's the Steven blacklist. So that's probably the most prominent blacklist. That's community driven and public. But you can also add more lists if you want. But you can also add domains manually using a domain filter or a regular expression. If you want to disable the blocking feature, or if you encounter any problems with specific websites or things that are not working, so you can further troubleshoot. Now, one thing that might be interesting to understand is what actually happens to the valid requests. So where are they sent to? Because we just changed the primary DNS server to Pi-hole, but where does Pi-hole send the valid requests to? So that you can configure in the settings when you go to DNS, and here you can configure multiple upstream servers. So by default, it is set to Google, but you can also change this to Cloudflare, enabling DNSSEC, or to Quad9 filtered, by the way, which will also filter out any harmful websites, malwares, and stuff like that. This is also, by the way, a super interesting service. This is an OpenDNS recursive service for free security and high privacy. This is a non-profit organization that gets its block list from various security vendors that provide their insights to Quad9, and they provide this free service. So then your DNS queries are being sent from your device to Pi-hole, and the valid ones are being sent to these upstream DNS servers. Now, you probably noticed that I did not configure this on my production DNS server, and the reason for this is that I still need my other authoritative DNS server, the bind9 server, for the local home lab domain resolution. So that is when I need to connect to some of my servers, like serverprod1.home.ccrave.de, or also my other domains that my servers or services are using. So that's the reason why I configured the upstream DNS server to my OpenSense firewall, and from there it's going to be sent out to the other upstream DNS server. So I kind of have added OpenSense into that DNS query chain. Don't be afraid of adding too many DNS servers in the chain that it's going to hurt your performance or something like this, because DNS queries are very efficient, they are very fast, and they're also being cached on all of the DNS servers. So don't be afraid of losing any performance when you're adding too many elements in the chain. But yeah, this is how you usually can build your DNS query chain, depending on what devices or servers you need in your environment. But if you don't have a bind 9 DNS server, if you don't have an OpenSense firewall, and you just want a super simplified setup, you can also use Pi-hole for adding static DNS entries if you go to local DNS records. So here, for example, you can add A records or CNAME records. For example, if you have like server prot1.home.ccrave.de and you need to resolve this to 10.20.0.2 or 192.168, whatever IP address you have, you can add these entries to Pi-hole, and if this becomes your primary DNS server, you can even manage simple DNS entries with that. However, I'm personally not a friend of this. As you might know, I'm using bind9 as my authoritative DNS server because it has a lot more features and is more capable as an internal DNS service. I really just use Pi-hole as a DNS black hole for any ads and trackers, and that's it, right? But just that you know, you can do all these things with Pi-hole if you want. You can even manage DHCP settings here. You need to specifically enable this, which I would not recommend you to do if you have a second DHCP server in your network. It will cause problems. So just do this when you exactly know what you're doing. But you can do it if you want. Create a start IP range, the router gateway's IP address, the subnet mask, and you can even add additional IPv6 support on Pi-hole. So you can see there are a few things possible in this software. I think it is really, really great. Absolutely for ad blocking and tracker blocking. This is the primary use case of this, where it just is an incredible and amazing tool for managing DNS entries. It can even do simple things, which might be enough for many, many people. But yeah, so that's it about Pi-hole. I think there's nothing more to say about this. It is really great. But now you can tell me your opinion. What do you think about Pi-hole? Do you use this in your home lab to block ads and trackers, or do you use some browser extensions or client-side applications? Please let me know in the comments down below. And also, if you have any feedback regarding the boilerplate CLI tools and the templates that I'm creating, please also let me know. You can create an issue on the GitHub repository if you encounter any troubles, or if you want other templates to be included in this tool. And as always, thank you so much for watching. Enjoy the rest of your day. Thanks so much to all the supporters and members of my channel. You guys are really making all of this possible. And of course, I'm gonna catch you in the next video. Take care, everybody. Bye bye.